Okay, OBS is recording. That's good because this is going to be a really quick video because I want to do a lot of projects and I'm planning lot of projects I want to do. And I've mentioned a few in previous videos and everything. And I've been buying up hardware so I can do these projects, so I can play with these ideas because it'd be awesome. It'd be amazing what I want to do. And one of the more simpler ideas I've been playing with is just, a basic tutorial series or even just a basic how-to series going through using microcontrollers like the Raspberry Pi Pico. You know, this little thing, the little green Raspberry board, the cute one. And since then, I've got one Raspberry Pi Pico, I've got two Raspberry Pi Picos, and along with that, I have a QT Pi with a SAMD 21 chip. Uh, SAMD 21 chip. A Raspberry. I believe it's a pink Feather with an RP2040. It's basically a Raspberry Pi but in the Feather format. And on this little board, which I've been playing with a bit lately, I have an itsy bitsy RP2040 with a accelerometer magnometer attached. And I want to do a video about this. I want to do a video playing with this and talking about how you can convert it from just being an accelerometer, getting a positive, negative acceleration based on gravity, yada, 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 and convert it into being used as a basic gyroscope. A very janky basic gyroscope with I believe it's God, I can't do the math right now because it's positive, negative XYZ plus positive, negative XY YZ XZ coordinates, for angular acceleration. But that's a whole nother thing. But I just want to make this short little video, saying I have planned projects, and I think a lot of them might, have to do with the itsy bitsy RP2040. Because this thing is small, this thing is cute, it's small, and it will actually fit with some of my projects. Because a subset of the projects I want to do lately, and this branches from my background as a 3D artist, is 3D printing and designing it props, like cosplay props that can be used interactively and have functions that aren't just, hey, it's a sword. Instead, hey, it's a sword that when you swing it a certain way, it lights up in a certain pattern, like like swords in the anime Demon Slayer, where they swing down the katana and it has blue, the blue water effect. But I mean, obviously, I can't have a trailing blue water effect in real life. But instead, just have LEDs light up in that pattern along the blade, based on the acceleration of the blade as it's being swung downward, and then based on certain other movements, it changes color. Cool stuff like that. And going through the process of designing the prop, going through the process of printing it, and putting it together, and even programming it using microcontrollers, accelerometers, LEDs. I need to get some LEDs, but NeoPixels are expensive, and basic LED strips are expensive. Like even I believe I've got one in here. Like even a basic strip like this, long enough to fit in like a katana's blade, which is about, I think, 2 feet long. Like I think like 2-3 feet long. That's long. That's like a meter at most, and that costs about $20 for a strip of LEDs. So that's a project for the future. But I want to work through the steps of it, make content based around the steps of designing something like that, and even make videos that based around, as I said before, just talking about each individual microcontroller, talking about their pinouts, how to how to use the pinouts, and be able to program the I2C, the SPI, the UART ports, how to assign those channels easily just by the pinouts. Because on some of these boards, like the Itsy Bitsy, you're able to, not the Itsy Bitsy, well, I mean, the best example I think of is the Cutie Pie. All you do is just do board.I2C and then get the pinouts of the I2C. But with something like the Raspberry Pi Pico, it's got two I2C channels, but a lot of their pins have I2C, so it doesn't have a dedicated I2C channel. So I want to make videos talking about how to do that, the functionality of that, and even going beyond that, using parts like give me a second, using integrated circuits. For example, using something like this, the MCP308. This is a multi-channel multi-channel input using, I believe it's I2C, or it might be SPI, I don't remember. And then I've got MCP2308 right here, and a 74HC595. And I want to be able to make videos about those, show the setup process, how to use them, and I personally think that would be really cool, just making videos talking about this hardware and going through the step-by-step of how to actually use it. Because that's where I see where people struggle. They follow a guide online, they're like, okay, I'm going to build this MIDI controller. And they just follow the guide, but they don't know how it actually works. So I want to make videos showing how to get to work, showing the process of getting from point A to point B, and just working through the steps of getting these devices working and why they work. The actual computer science behind it, the actual programming and development behind it. And I personally think that would be awesome. So yeah, this was just a quick update video showing off some of the hardware I got. I'm gonna be ordering more microcontrollers sooner or later, because I personally want to get a Cutie Pie RP2040, the Raspberry Pi Cutie Pie, along with an ESP32 Cutie Pie, just so I can be able to compare them. Because I know they all have different clock speeds, different amount of RAM, different amount of storage. This thing only has, I think, 32 kilobytes of RAM, which isn't a lot, but that's for later. Right now, I just want to do a quick update, and yeah, I hope you all have a good day. I hope you all have a really good, fun time tinkering and building cool stuff, and let's see what I do in the future.